Like I mean, I have my answer key here, but I'm gonna probably go off like on a different, I'm just gonna give it a different approach. Okay. I didn't do the volume for page 14 yet, I know that. How about I'll do another video where I go over how to do the volume. Surface area is the hardest one. So let's figure out the surface area of this, okay? And you have to imagine, obviously this piece of this tape roll is not as tall as this, obviously, but I thought I would use this to help us out. So if you think of that view right here, it's this tape, right? So we have to account for this part right here, that surface area. And we have to account for the inside here as well. Okay, that whole inside of this cylinder. So it's almost like you have to consider the outside. You have to consider this lip, right? There's one on either side. And you have to account for the smaller cylinder inside. Okay, because surfaces, if you had to paint this, I always like to think if you covered it or painted it, what areas would you have to consider? Right, so I'm thinking the side here, the outside, this times 2, and this, right, the inside. So that's what's going to happen here. So how are we going to achieve that? I'm going to call this total surface area. If I just want the outside, like should I just do the outside or should I also do the entire circle here? As if it's covered. I don't have I should cut out a piece of that is in here. But I will actually consider this at first a closed cylinder, a big closed cylinder, okay? So I'm going to go surface area of large cylinder. I tell myself what I'm going to do first. Surface area, okay? Plus, what can I add here? I'm gonna consider that inside, that smaller cylinder, but I don't need the top and the bottom of it because it's hollow, right? I just want to add this part right here on the inside. So what do we call that? We call that lateral surface area of the small cylinder. Okay. And but how do I account for this is hollow, this is open now, right? So I just want this piece right here. So what I'm going to do is I'm going to pretend like the large one, when I calculated the surface area of the large one, I pretended like this was completely closed. So I'm going to subtract 2 smaller circles. Does that make sense? I'm going to subtract that. So I'm going to go minus 2 small circles. And that will do it for this one. I want to say something. Do we have a formula for this shape right here? For just like a donut? We don't. So what's happening here is you're gonna, if this is the top view where this is completely closed, you have to take away this small circle, right? Like this is what we're gonna subtract from both ends, right? We're subtracting that small circle from the top, right? We're subtracting it from the top and we're subtracting it from the bottom. That's why I'm subtracting 2 small circles. I'm taking those 2 away from the large cylinder, okay? So, surface area of large cylinder, 2, watch what I'm gonna do here. I'm gonna use capital R to refer to the radius of the large cylinder. 2 pi r squared plus 2 pi r, and I'm going to use h. H doesn't matter if you have capital H or lowercase h. because the heights of both cylinders, the inside and the outside, have the same height. So you don't need to make a distinction there. So this is this first part, this one, plus I just want the lateral surface area of the inside. So that is what? 2 pi lowercase r h. Minus 2 small circles. So that would be 2 times pi r squared. And I want to kind of let you just think about it a little bit. Right? You have to know, to begin with, you know how some of you might have thought of a small cylinder? Well, shouldn't it also look like this, Mr. Dixon? Like, this is the large cylinder, and then the small cylinder, shouldn't it look exactly the same? The answer is no, because remember what we're doing here. We're taking this large cylinder on the outside here, and we're pretending like it's covered for now at the very beginning. So we're including this top circle and the bottom circle, the whole thing here. Okay? If you want to, you could have actually first thought of, well, why don't we first then subtract the 2 circles, the 2 small ones. Let's subtract them because we added the whole thing. Okay, the whole thing. Let's subtract the 2 circles. So if it helps you to put this bracket right in here next to that one, that is also okay, right? If the order matters to you, that is something that we would have had to do. And then we go plus 2 pi rh, which is just this. We don't want the top and the bottom of the small cylinder because it's not here. You can look right through, right? It's not there. It's not a surface we want to add, okay? Are we good? I wish I had a better visual, but we'll work through it and hopefully that works out. So let's calculate this. 2 pi, what is the radius of the big one here? Let's do that right here. The radius, capital R, goes from end to end, which is 12.5, right? We just divide that in half. So I'm going to use that here. 12.5 squared plus 2 pi 12.5 times h. H is the height of the cylinder, which is 64.5. Close it. So this whole thing turned out to be this after substitutions. Plus 2 pi, what is the radius of the small cylinder here? 10? Yeah, 10.5. 10.5? Okay, I will do this though, okay? If this is 2 here, this is 2 as well, correct? So we're going to go 25 minus 4. We're at 21. Half of 21 is 10.5. So a lot of stuff going on. Okay. So 2 pi r, r is now 10.5 times the height. The height is still the same, 64.5. Close that. Minus 2 pi r squared. Boom. That is your surface area. So grab your calculators. I think it's safe to say that you can type in the square brackets in one shot. 2 pi 12.5 x2 plus 2 pi 12.5 64.5. That's 6,047. And we're going to use all decimals, right? So this whole thing amounts to that, plus 2 pi. Please let me know if I make a mistake, because it sucks to make it right to the end and figure out that I typed something in wrong. All of this amounts to that, minus two pi r squared. 692.72 something. Dollars, sorry. Money. Okay, let's see if this works out. So copy paste, so that plus that minus yes, got the same answer as my key. It's always a good feeling. And we are in centimeters squared. That's the total surface area. Practice. That's it. You're looking all serious, guys. Serious. Okay, let's do the volume. Total volume. Volume is easier. You don't have to worry about the exposed faces. Yes?
So slanted surface area is just a surface area without the faces?
Slanted? You mean lateral surface area?
Yeah.
Lateral surface areas that don't include the base. Or for a cylinder, lateral just means the sides, right? Like you just want the sides. You don't want the circles at the top or bottom. That's why the formula is just this. Yeah. Total volume, you're going to go volume of large cylinder. You're just drilling a hole. You're just taking out volume. Minus volume of small cylinder. That's it. So what's the volume of the large cylinder? Pi r squared times h minus pi radius squared times h. We already know what our radii is. So this would be 12.5 squared times 64.5 minus, oh, sorry, this is not 12.5. This is the small radius, which is 10.5 times 64.5. And then just plug in and go. I'm going to go pi times 12.5 squared. It's 31,661.36. That keeps going minus. I'm just going to copy paste the work actually. Copy paste the work, just change the radius to 10.5. and then just subtract them. That one minus that one. This is centimeters cubed. Yeah.
How many marks would each question get, like, for?
Something like this would probably be 3. Like finding the volumes and then subtracting, so 1, 1, 1. Something like this top one is probably worth 4. Let me see if I can help you out. I think the part that a lot of students miss is that when there are holes, you need to omit, you need to like ignore parts of formulas of the shapes you're recognizing, and you need to subtract due to the fact that you've created the hole. So some students don't understand that you have to add, because now that you drilled that hole through the shape, you've actually inserted, there's now exposed face, an exposed face, right? When you drill through this, you're exposing that side that was inside that shape previously. So you go outside, inside, I add that, and then I subtract the hole, the shape of the hole. I subtract that. In this case, it's a circular hole, right? If this had been a square hole, instead of subtracting 2 circles, you would have subtracted 2 squares, right? And what would you have added if this was a square hole? What shape do you create inside of this when you, right? There's 2 rectangular pieces in here. I wish I had a shape with a rectangular hole. I need to use, I have a 3D printer at home, but it's probably full of dust. So I need to like shake that dust off. Can you go to 16 and try that one? How about we talk about, yeah, I'm gonna stop this video and start a new one.